It's about China's maritime capabilities. Briefly to introduce Mr. Chengappa, he is Associate Professor at Christ University in Bangalore and teaches international relations along with strategic studies. He has worked as a senior research fellow with the Institute for Defense Studies and Analysis in New Delhi for 4 years. And he's written for many newspapers, and he has worked for the Deccan Herald and the Indian Express and written for them, and also for the Hindu Business Line, mostly on defense, industry and military R&D matters. He holds a PhD in Indian foreign policy towards China in the post-Nehru period and a master's in defense and strategic studies from the Madras University. He has authored 2 books, India-China Relations Post-Conflict Phase to Post-Cold War Period, and Pakistan, Army, Islam and Foreign Policy. He also has a research monograph titled Pakistan's Fifth Estate, the Inter-Services Directorate. Over to you, Mr. Chengappa.
Thank you, Shashi, for that nice introduction. Now, the next topic is about China's maritime capabilities. And I have the privilege of introducing 3 distinguished speakers. First is Commodore Gopal Suri, who's going to speak on overview of China's ports and shipbuilding capability. The Commodore is a senior research fellow at the Center for Contemporary China Studies in the Ministry of External Affairs. He steers studies on China's international relations, including the One Belt, One Road initiative. He has authored a book on China's expanding military maritime footprint in the Indian Ocean region. He has been a senior fellow at the Vivekananda International Foundation in the field of national security and strategy, focusing on maritime security in the Indian Ocean and Indo-Pacific. The officer is a serving submariner who has commanded a frigate and a submarine in his naval career. He has also held the appointment of Principal Director Submarine Operations at Naval Headquarters in addition to other staff appointments. Over to you, Commodore Sab.
Thank you, sir. I'll just quickly...
Yeah, with the permission of the chair, just one small intervention. I forgot to mention that we've had to make a small adjustment in terms of speakers. I just have a request from Dr. Venkateshan, who was scheduled to speak tomorrow, and he has requested that he be included today before lunch. So we have an extra speaker. This may be kindly noted by Dr. Chengappa, who will, Dr. Venkateshan will speak from 12:40 to 1300. And the question answer session will be thereafter. Sorry for this intervention, but I thought I will let you know so that the timings are suitably adjusted. Thank you.
Thank you, sir. This is Commodore Suri. Thanks so much, sir, for having me on this very interesting panel. I'll quickly start without wasting too much time on China's ports and shipbuilding capability. A caveat at the beginning, I have restricted myself to a broad overview and I don't intend going into the details of each for paucity of time, and also not the naval aspect. I would be very happy to answer any questions to either of these issues. Before I actually start my presentation, I thought I would like to just bring into perspective China's maritime ambitions. Admiral Lamba alluded to it. China's desire to be a strong maritime country. Many people read it as a strong maritime power. This is very clearly stated in the 12th five-year plan. So I don't think one should have any doubts about China's long-term ambitions. How they're going to fructify is what it does through various domains, ports and shipbuilding being one. Admiral Lamba had also talked about China's vision of achieving global naval presence by 2050, that is just after the 100th anniversary of the PRC. They've also been repeatedly talking about asserting the maritime rights. Practically every defense white paper has had this issue there. Of late, starting with the white paper in 2015, which was China's military strategy, they've also talked about expanding the maritime rights and overseas interests, which is key to understanding how they're going to go about fructifying their maritime ambitions. Another unstated one, but talked about in many fora, is China's desire for a reform of international governance, which finds its reflection even in the maritime domain. in terms of how they are trying to change international laws, how they're trying to train international jurisdiction. For example, year back, they opened maritime courts in Shanghai. Now, coming to the subject of my presentation, ports, I thought I would put across some statistics to give a feeling as to where China stands in the world. The figure that you can see on the screen is taken from Lloyd's list of top 100 ports, basically the container ports. I won't go into the details of the bulkers and etc. because this trend is reflective even in that domain. As you can see, 7 ports out of the top 10 are in China. Barring Singapore, Dubai and Busan in Korea, the rest are all Chinese. And just to give you the scale, JNPT, which is India's port in the top 100, figures regularly at about 33 to 35 in the number, handles just about 5 million TEU as compared to Shanghai. It's incorrect comparing the two. The scales are vastly different. What are the number of berths? This gives us idea of the handling capacity of the berths, handling capacity of these ports. What I've put on is only those berths which handle ships of more than 10,000 tons. As you can see, the Chinese are in a league of their own, especially the ports of Shanghai, Ningbo, and Guangzhou. Just to again bring the Indian perspective in mind, the Ministry of Shipping report last year totaled 251 ports and 9 single buoy moorings for India. Compare that with what each individual Chinese port has. Now, what are the volume of freight that these ports handle in terms of major commodities? I've just listed out a few commodities. For example, coal and products is in excess of 1.6 billion tons. And just again, to bring the Indian perspective, we handled about 700 million tons in all goods at the 13 major ports that we have. Now, how did this huge port construction come about? During the Mao period, he wasn't really looking at the coast for driving Chinese economy. In fact, he was the propagator of the third front, which was inland industry. However, with Deng Xiaoping coming in and the focus, a very fine focus on development of the Chinese economy, realized that foreign trade was important, and consequently the focus on ports. And that focus has been retained on port construction, port expansion, right from then till now through the 5-year plans. The 6th 5-year plan, which was immediately after China's opening up, called port development as a strategic focus, and that has been retained till the 13th and the under discussion 14th plan, which was recently talked about at the 5th plenum just about a month back. Then China created the port development framework in the early 90s with the idea of addressing various issues towards ports. They looked at development of ports in a hub and spoke model. So they had some pivotal ports, which are going to be the main ports, and other ones surrounding it. Consequently, all development was done through this framework, and development of even medium-sized and small ports was done to suit this model. The early part of the 21st century, which continues till date, Chinese are focused on increasing efficiency and the scale of operations. Port sizes have increased, port efficiencies have increased. For example, handling at the index by which handling of containers goes by, on that, Shanghai takes about 0.6 days, whereas India takes about 0.9 days for handling 100 TEUs. Similarly, in 2003, all this effort came to bear in terms of China becoming the #1 port handler in the world. They achieved the throughput of all the major ports of about 2.6 billion tons, a position they've continued till date. 16 of China's ports handle more than 100 million tons annually since then. What are the major enabling policies? The government has, obviously, with the focus that Deng Xiaoping gave, subsequent administrations under Jiang Zemin and Hu Jintao, and of course Xi Jinping now, have retained this focus. The start of this was the Maritime Code, which basically laid down the ground rules for handling and interacting with various entities in the maritime domain. A distinctive feature of this was the allowance of foreign companies for the first time to operate ports and administer ports in China, albeit through joint ventures. They can't, the Chinese foreign companies are not allowed to operate independently. China then promulgated the port law in 2004, 1st Jan to be precise, which loosened the centralized control that the State Council had excised till then. So now provinces and cities could administer and operate ports. However, the caveat being the ports were to be developed in consonance with the directives of the State Council. That is, the location of ports would be decided. Administering and ports could be done by the ports, and in fact, in province or city administrations. Then 2006 saw the national plan for coastal port layouts. China realized that ports were growing a dime a dozen. They were all over the place. It was becoming unwieldy. So they laid out 5 port groups, which I'll show in the next slide, starting from north to south: Bohai, the Bohai Sea Area Group, the Yangtze River Delta, Southeast Coast, Pearl River, and finally the Southwest Coast. The 5-year plans, like I mentioned earlier, the focus on port was retained, and off late in the 13th and even the 14th, they are looking at integrating ports, not just for handling foreign cargo, but also into the national transportation. In fact, they talk about using ports as intermodal transportation hubs. Now, what I said, the coastal port groups, as you can see, the northernmost is Bohai. I will talk a little about that. And then so that you understand the model that they follow. For example, in the Bohai group, it consists of 2 groups actually, one around Liaoning and in Shandong. So if one were to look at Liaoning, there Dalian is the center, which is the mainline port, say for containers. And then Yingkou, Qinzhou, and Tantong are the branch feeder line port. They follow this model right through, which has helped them avoid overlap or responsibility. And also these ports cater to the hinterland. For example, say if one was to take the southernmost one, that is at the southwest coast, it caters to the regions of Guangxi, Yunnan, and Guizhou also. So that's how they work. What are the current and future initiatives? The One Belt, One Road has been talked about quite a bit. The ports are the springboard for the 21st century maritime Silk Road, which is part of the One Belt, One Road initiative. The coastal regions are the ones which are going to create the springboard for taking this initiative west or into the other regions, as I won't go into the details of the One Belt, One Road. For example, development of the Guangdong, Hong Kong, Macau, Greater Bay Area, or for that matter, the Zhejiang Marine Economy Development Zone and others. Similarly, China has been acquiring ports, stakes in ports, developing ports, taking control of port operations, both state entities as also private ones like Hutchison, all throughout the world. I have a map on the Indian Ocean region, but I'll save that for later due to wanted time. China is also looking at developing free trade zones and ports. For example, Shanghai Free Trade Zone is right now in an experimental stage, but that is going to transition to other places like Hainan, etc. Last year end, they put out a guideline for accelerating the development of ports, and they have some clearly lined objectives in that, aims, so to speak. They have aimed to become green, smart, and safe ports in keeping with their commitments under UN Sustainable Development Goals by 2025. They aim to hold all the major world-leading ports by 2035 and the world-class port clusters around the 5 areas that I mentioned earlier by 2050. They've also stepped into the next generation, that is automated operations using 5G, using blockchain. In fact, in April, Costco tested out automated loading using driverless trucks at the Xiamen Ocean Gate terminal. This is as far as ports stand. Now moving on to the next part, shipbuilding. Again, I'll put out some figures here to get us understanding of the scale of China's shipbuilding. They're the world's leading shipbuilders. As you can see from this slide, they construct more than 1/3 of the world's ships. And this is in compensated gross tonnage, which is meant to cater across various various types of ships to give an understanding. This is a technique which is followed throughout the shipbuilding world. Some deliveries of new build ships, what they made out last year. Here, I will draw your attention to especially five categories: bulkers, oilers, container ships, gas carriers, and chemical tankers. As you can see, bulkers, China constructs more than 50%. Oil tankers, again, nearly 50%. Container ships, almost 30% and more. However, in gas carriers, chemical tankers, and say even passenger ships, they are well low. This is because these classes of ships, the three containers, gas carriers, and are more complicated, technologically more complex, whereas bulkers, oilers, and containers are simpler ships to construct. And I'll come to the whys and hows of that a little later. Ownership of the world's fleet, way ahead. I put in a slide of India here, just again to give a context to where we stand. Suffice to say, China is, like Admiral Lamba had said in the morning, they're going to be leading the world in terms of ownership of the world's fleet, whether registered in China or abroad under the Chinese flag. To bring in the naval element, I thought I'd put across the last few years of construction, which I've been compiling over a period of time. As you can see, large ships, I've of course talked only about the large ships here, are not taken into account the fast attack craft, which are numerous. For example, corvettes, they've commissioned close to 10. I may be off by 2 or 3 this year, considering the opacity of the information that China puts out. But notwithstanding, they construct about 4 to 5 destroyers a year, 3 to 4 frigates, corvettes, about 8 to 10. That speaks a lot. Now, what has been the course of Chinese shipbuilding over the years? The 6th Ministry of Shipbuilding, right from 1949 to 1982, was the one dealing with shipbuilding across China. However, China realized this was not getting them too much of a market share in the rest of the world, and then they created this corporate entity called China State Shipbuilding Corporation in 82. This corporatization also helped China to get a market outside through foreign partnerships, which CSSC was allowed to. Secondly, CSSC agreed to certification by Western agencies. So combined with the inherent benefits that Chinese shipbuilding had, this allowed them to expand the market share.
Commodore Suri, you have about 5 minutes left.
Roy, sir, thank you. In 1999, CSSC had become pretty unwieldy because of the size, and since it was a huge expanse of control, so the Chinese state decided to split up CSSC and created CSIC, which is the China Shipbuilding Industry Corporation. And they had a geographical distribution or responsibility, with CSIC looking towards the north of the Yangtze and CSSC looking to the south of the Yangtze. Along with this, there were also a number of provincially owned shipyards. For example, like the Jiangnan, in other places, and also a number of JVs also came about with Japanese yards, with Korean yards, even Europeans. And consequently, there was the forming of these shipping conglomerates like COSCO, the China Ocean Shipping Corporation, also holding yards. The PLA Navy, meanwhile, continued to retain a few yards for their own specialized manufacture, as also for repair and repairs. However, last year, towards the end, actually, it's a process which started sometime in 2018. There were rumors of that. That came about with a merger of CSSC and CSIC into the China Shipbuilding Corporation, which is a megalith now, which controls all shipbuilding in China. Possibly this has come about because of overcapacities, maybe a shrinkage of the global market also, so as to synergize the two entities' strengths, resources, manpower, and also cuts of pay, etc. I won't go into the details of that. I would have definitely welcome questions on that later. Now, this is the map of China's shipyards as they stood last year. However, you could look at CSSC and CSIC together. The demarcation here is clear. You can one can see CSIC to the north of the Yangtze and CSIC towards the south. The green colored ones are the private and the JV shipyards, and the others are, of course, the PLA Navy ones. I'm sorry, some of the figures are blurred, but then this is something I got out from the open source. Now, a quick look at the naval shipyards and their dispersion along China's coast. Hulutao is where they make the submarines. Dalian is where they made the first aircraft carrier. The next one is being made in Shanghai, which is, of course, the big center of shipbuilding, both for naval as well as for civilian. Wuchang is where they make some of the submarines, which is fairly inland. And the others centered around further south, around in Guangdong and Guangzhou. Moving on to the enabling factors, labor obviously comes to mind, inexpensive. And for example, in 2004, when they started going global with their marketing, average Chinese labor would get about $240 a year, whereas comparatively in Korea, it was about $1,400. The corporatization of shipbuilding structures, which I mentioned earlier, also helped them quickly get JVs, get foreign expertise in. Importantly, the Chinese state, by some yardsticks, CSIS in the US had done a study, claims that they pumped in about $1.27 billion of direct funding last year. Then, of course, indirect through subsidies, tax exemptions, reinvested profits. Interestingly, both these entities, which of course is under the CSA now, they own the independent research and development institutes, which help them dovetail requirements for the consumer, specific ones. Similarly, as I mentioned repeatedly, on the focus on shipbuilding.
Commodore Suri, 2 minutes more, can you wind up?
Yes, sir, this is the last slide. Some weaknesses and limitations. While they are the world's largest shipbuilder, availability of advanced shipbuilding and design technology is fairly limited to just the larger yards and a few of them. Interestingly, they also lack specialized steel production, especially for making the gas tankers. As I had also mentioned during the merger, overcapacity and reduced fund availability has been plaguing some of these yards. They also rely on imports for stuff like navigation systems, main machinery, electrical, etc., which in today's world, especially with the geopolitical pressures on China, they could find problems. Many of these yards are focused on bulkers, and hence diversification has been limited. So their ability to adjust to markets and shorten supply, which is what is the case now, is difficult. I have finished here. I would definitely welcome questions on these subsequently. Thank you so much, sir.
Thank you, Commodore Suri. Nice listening to you. The next speaker is Commander Arnab Das, who will be speaking on India-China face-off, need for underwater domain awareness. Commander Das is a researcher, maritime strategist, and an entrepreneur. He is the founder and director of the Maritime Research Center that is working on a unique concept of underwater domain awareness as its main focus. He also runs his startup Neer Dhwani Technology, which provides consultancies and services for high-end maritime security solutions and marine conservation support. Commander Das served in the Indian Navy for over 2 decades. He did his master's and PhD from IIT Delhi as a uniformed officer and undertook several R&D projects during his 7-year R&D tenure at IIT Delhi. He was invited to Tokyo University as a visiting researcher for his work on freshwater dolphins, and post-retirement from the Navy, he worked at the Acoustic Research Laboratory at National University, Singapore. Commander Das, all yours.
Thank you so much, sir. Commodore Vasan sir and Commodore Uday sir, thank you very much for this opportunity. It is indeed an honor for me to be presenting my work on this forum. So today I'll be focusing on the India-China face-off, need for underwater domain awareness. A lot has also been said about the underwater technologies and underwater domain awareness. So I have a specific focus which I would like to bring out through my presentation. So I'll try and cover my presentation under these following heads. When we look at the 21st century new global order, we can definitely sense the entire maritime focus has come into the tropical littoral waters. During the Cold War era, where the maximum technology development happened in the underwater domain, but now we are seeing the entire naval theater and even commercial activities shifting to the tropical littoral waters, and there is definitely something more that we need to discuss when we look at the tropical waters. Now, the Indo-Pacific strategic construct is definitely something very, very important, and a lot is being said and being kind of pushed as far as the Indo-Pacific strategic space. But when you look at the strategic space, Indo-Pacific strategic space, it is the entire tropical waters of the Indian Ocean region and the Pacific Ocean. So we need to understand what this tropical littoral waters mean. One thing I would like to say that when we talk about the tropical waters, the littoral water term gets automatically added because acoustically the entire tropical waters can be considered to be shallow, because the definition of shallow versus deep water acoustically has a very different meaning or a connotation, not directly related to the depth per se. So that is something we all need to appreciate and understand. So, I mean, I don't think I need to elaborate too much on this. The Quad has become quite synonymous to the Indo-Pacific strategic construct. Evolution of Quad, we all know, and I think a lot has been said and will be said going forward. But the most important thing is India's centrality in the Indo-Pacific. And also it has its own implication on the Indo-China relations. But the most important thing which I would like to highlight is the Indo part of the Indo-Pacific. I mean, what is it that we take away from this, and what is it that we need to focus on in terms of capacity and capability building? Now, India in the 21st century is something very, very different that we are aware of. Now, we have the Sagar vision. We are a nuclear powered nation with no first use declared policy. We have a strategic submarine deployment, aircraft carrier operations. So everything has a underwater domain awareness component to it, and that is what I would try to discuss. So the Sagar vision, I don't think I'll discuss too much. It has got typically 4 aspects: the security concerns, the growth opportunities, and the leadership role that we envisage for India in the Indian Ocean region. And definitely we want to revive our rich maritime heritage. So now this is something very important. We have a nuclear powered nation with no first use. So the importance of a strategic submarine becomes very, very critical. I would like to draw your attention to an incident. In '88, when we had the first Chakra and it was deployed off Vizag, and when it sat down in position, the entire sonar screen got blanked out. There was a brainstorming, and the Masab, who has a lot of experience, came up with the idea that we will do blast transmission and everything will be okay. So the captain, Admiral Ganeshan, thought for a while and said, yeah, I think that is the only option. But we all know that a transmission by a submarine on a mission is suicidal, if I may use the word. But they did that, and of course the sonar screen was fine. I will take you back to 1952. I mean, when the Nautilus was supposed to be deployed. In 1946, the Scripps Institute of Oceanography did a snapping shrimp mapping across the world, because strategic submarines are not for your waters, they are for the larger international waters. Now, what we draw out of this is that snapping shrimps generate sound of the order of 200 dB, reference 1 micropascal. Whereas even a blue whale, which is the biggest mammal, generates sound of 196 dB. Whales are in few numbers, in probably less than 10, but snapping shrimps are in a million. And it is known that the tropical waters is a habitat of snapping shrimps. I mean, something we need to, I mean, we are getting into a very different dimension of deployment. So this is something, when I was trying to tell somebody, when I was still serving, they said, don't worry about marine mammals or marine species. That is not your job. But I think that everything has an implication and we need to look at it. So in MRC, we have done this complete study, and we have generated the snapping shrimp map. We have also created soundscapes, which it will generate. But there are also a lot of civilian applications to this. I mean, even the shrimp farming can use this kind of map and this kind of inputs for enhancing their commercial outputs. So capacity building, we are all aware of. So when we talk about the underwater domain awareness, this has to be looked at very holistically. I mean, we call it a safe, secure, sustainable growth model, where security, disaster management, sustainable growth is all taken hand in hand. How bad is it in India? We had these incidents. First is a 40 feet blue whale that was stranded south of Mumbai in May 2015. Then second is a 50 feet bride whale near Karwar, which got stranded. These two I have investigated, and I have published this in a journal paper, and it is attributable to the anti-piracy operation that has been going on. The entire shipping lane has shifted, and there is a massive disruption to the migration pattern of these marine mammals. The third is the 90 pilotless whale that got stranded off Tuticorin. Now, let us look at China. Now, towards the end of the Cold War, there was a feeling in the American establishment that now there is no challenge for them. So definitely they had started lowering the guard. But toward the end of the last century, the Americans realized that China has definitely developed tremendous underwater capabilities. So what they did was initiated this exercise called Asia X, because if they have to counter China in the South China Sea, which is a tropical waters, they need to have a different understanding, because the entire understanding of the underwater medium characteristic that was developed during the Cold War by the Americans was in the Greenland, Iceland region, which is a temperate or a polar region. So they initiated this academia-led, University of Washington led the first phase, and the second phase they also included, to avoid any kind of diplomatic backlash, they included universities from China and locally from Hong Kong, Taiwan, and others. And it was a massive shallow water acoustic measurement exercise. The takeaways for US was, of course, very, very clear, that they wanted to have much more data and do a lot of modeling and simulation. And University of Washington had very well developed modeling and simulation capabilities and data analytics capability, and they wanted to validate, so that Asia X was launched. But takeaway for China was also very, very interesting. They knew that such an exercise cannot be done by them alone, and they were definitely having a massive plan to do their acoustic capacity building. So they participated and they learned from it. And I have met some people in 2016 when I was in Shanghai. But follow on is even more interesting. I mean, after Asia X took about 3 years of data collection. And those data is even now available with the US universities to kind of do the research and develop their underwater domain awareness capability. But one interesting thing is, when President Trump was elected and he was yet to take over in 2016, there was a Chinese drone, which was American drone, which was captured by the Chinese. And this was a signaling by China that now we are ready and you cannot be doing what, because America was routinely deploying drones and underwater system acoustic arrays to continue with their data collection. So this is something we need to keep track of. And you know, after 2016, what has been going on in the South China Sea. In 2015, China also declared in open source that they have this underwater Great Wall project. So this is something we need to take note of. And this was, I mean, underwater Great Wall project is not something which has been done in a couple of years. It was almost, I think, 2 decades of work. So this was a well strategized plan driven by the government. And China also, in the last 15 years, we have been seeing a lot of acoustic institutes, and every major university there has a massive department where they talk about underwater robotics and acoustic analysis. So now when we look at the Indian Ocean region and the challenges, we have pre-modern states which are very fragmented and geopolitically also. And so it is allowing extra-regional powers, China being one of the major ones, but many other countries. If I may say so. So it definitely disrupts the Indian Ocean region's ability to take forward safe, secure, sustainable growth. So India definitely needs to play a role. And if you look at the environmental or sustainable growth model, the Kuznets curve is something which is very, very well established. So we are probably in the first dotted line, and it is time that we all come together in the Indian Ocean region and definitely come up with regulatory plans on a regional framework where we can understand the underwater domain awareness and bring a regulatory framework which can promote sustainable growth. These binaries, I mean, not just in the region, but I think within the country also, we have different stakeholders not cooperating, or we have, if I may use the word, turf war. I mean, whether it is development versus security. So these binaries need to be demolished, and we need to work together to take things forward. Now, particularly, it is very interesting for us to understand the development of underwater technology. I mean, probably the start point was the social system, which had such amount of data collected for underwater analysis and by acoustic capacity building that but towards the end of the Cold War, these started getting demolished. I mean, the Point Sur naval facility, which was set up in 1958, had to be shut down in 84 because the American establishment could not afford it. The ship shock test had to face environmental backlash, and they had to shift US Navy had to shift the location with consultation from the environmental groups. The Greek whale stranding is another interesting thing where American sonar was being tested on a NATO ship off the coast of Greece, and there were 17 whales which got stranded. And Dr. Antonio published it in Nature, and there was a massive backlash, and this probably became a focusing event. So the American Navy was forced to accept that this is attributable to their testing. But and the US president had to use his special powers to avoid a complete ban on sonar trials, and they had to agree to fund research. So, I mean, what I'm trying to bring out here is that now the security establishment cannot expect unquestioned support in terms of resources, and we have to find ways where we can work with other stakeholders for science and technology development. So, I mean, the tropical littoral water conditions are very well known, and I think the sonar performance degradation, I mean, we have experienced that a sonar which was tested in the Greenland, Iceland area or around that, when it comes here, there's tremendous degradation in the performance, I can say, of the order of about 60%. So even if we can build capabilities, I mean, I'm talking about, this is a hardware versus software debate, where if we can build capabilities of algorithms that can even make the present ranges double, it will help everybody and requires massive effort. Now, maritime domain awareness has become very, very synonymous to, I mean, and these are event-driven, as I say, post the 9/11 in the US and in India 26/11. But it remained a security-driven formulation. I mean, there is a very good paper by Commander Borres, maritime domain awareness myths and versus reality. And even in the American establishment, he finds that UDA still requires, or UDA still has a distance to cover. But I think across the world and including India, I think UDA has not been given enough priority. But my worry is that being a security-driven formulation, it prevents the participation by other stakeholders. So it is important that we find a mechanism where we can have a pooling of resources and synergizing of efforts across stakeholders. So, I mean, the UDA framework proposed by us, I mean, I don't think I need to explain this, but we'll quickly go through various stakeholders. National security, whether it's external security or internal security. We've had the Kasab incident. I think today is a very remarkable day. It's an anniversary of the 26/11 incident. But are we expecting that the next time friends of Kasab are going to come by a surface vessel? I mean, there is so much of disruptive technology already. Sakuja sir has talked about it, and a whole lot of things that are available. So what is our preparedness is something, you know, we need to be looking at. I mean, how do we put boots on the ground to make sure that we have a significant presence? And I don't think our security forces will have enough bandwidth to cover the requirement. We'll always have the resource crunch, and there will always be budgetary limitations. So how do we take this forward? I mean, typically the capability building is important. Coming to the blue economic aspect, I mean, I want to draw your attention to the second picture of fisheries and fish finding sonars. I mean, the global fish stock since 1996 is on a decline, but the bycatch in most part of the world, and definitely Indian Ocean region, because it is so much unorganized, it is
Although you need to wind up in a couple of minutes because we are running short of time. Thank you.
Yes, sir. So we need to have a lot of technology coming into it and a lot of organized thing to minimize the bycatch and definitely make it more efficient. And definitely environment and disaster management will become a very, very important thing. There are various components, probably we'll not go into the details of this. Acoustic habitat degradation, I mean, the noise pollution is a very, very important thing. I've just talked about it a little bit, but that needs a lot of requirement. And definitely science and technology. I mean, we have 20 lakh square kilometer of area. So definitely data science and artificial intelligence is inescapable. So we need to build systems. I mean, now we should not waste energy in anything else, but to focus, how do we build smart systems which can give us the complete picture? This is the framework that we have developed. If you look at the 4 faces of the cube, the horizontal construct, as I call it, they represent the various stakeholders, that 4 stakeholders that we mentioned. But the core will be the acoustic capacity building. We need to have sonars which can give us much better performance. So we need to all come together, spend time and effort on, and have sustainable plan. I mean, the tropical littoral water challenges are not something very simple. We need to, and if you look at the vertical construct, a lot of sensing is required. Typically, we have been importing regulations or policy from somewhere. I don't want to name organizations, but we have no understanding of our own conditions. So sensing, application specific analysis, and then we look at policy. So, and when you look at these smaller cubes, everybody needs to participate. I mean, I think more participation is required, mass participation in terms of young students doing project. You can be addressing smaller cubes of this larger cube and contributing to it so that the understanding is better. There are hardly any academic programs that are driving this. So this is a map that we have created, which gives you a sense of the low frequency noise. And this has been converted from the AIS data into, I mean, the shipping traffic has been converted to low frequency noise. This map can be used for various purposes. I mean, from a military purpose, we can look at submarine deployment using this, but from a marine mammal perspective, conservation perspective, we can do conservation plans more effectively with this kind of underwater domain awareness. And a complete
Commander Das, you have 2 minutes left.
Yes, sir. I'll follow the time, sir.
Yeah.
So this is just an amplification of the UDF framework for underwater radiator noise management. Navy has a requirement of acoustic stealth, but the same thing can be used for by the environmental groups on acoustic habitat degradation, and also ship designers and ship builders. So we have created many such things like sediment classification for water resource management, for inland water transport, even deployment across water bodies. Similar thing can be done. And this is the larger UDF framework. I mean, a lot of programs by the government can be brought under this UDA opportunities, and we can look at policy, technology and innovation, and human resource development. And you can see the various stakeholders who can benefit out of that: oil and gas, port management, a complete sense of the underwater domain awareness. So that's my last slide, sir. Thank you so much.
Professor Chengappa, are you there?
Yeah, I'm there. Now, the next speaker is Professor Rajaram Nagappa, who's going to speak on geospatial surveillance for maritime and coastal security. Professor Nagappa has specialized in aerospace propulsion and has worked extensively in the design and development of solid propellant rockets. He has served in the Vikram Sarabhai Space Center, ISRO, in various capacities and retired as its associate director. The solid propellant motors powering ISRO's PSLV and GSLV Mark II, which are among the largest in the world, were developed under his leadership. After retirement from ISRO, Professor Nagappa was with the Anna University, Chennai as Pandalai Memorial Chair Professor with Technikon, Israel Institute of Technology, Haifa's Lady Davis Visiting Professor before joining the National Institute of Advanced Studies in 2007. He is currently Honorary Visiting Professor with the International Strategic and Security Studies Program at NIAS. Professor Nagapa's current research interests include ballistic and cruise missiles, space policy, and space security issues. He has a number of publications on these and aerospace-related topics. With that, I will give the floor to Professor Rajarang Nagapa, sir. All yours, sir.
Thank you. I'm trying to see how to share my screen. I'm just trying to bring this on.
Yeah.
A little bit of difficulty. It says can't share my screen. I don't know what exactly is wrong. Aishwarya, are you able to?
Professor, I have your slide, your presentation with me. Shall I go ahead and screen it?
Please go ahead. I wouldn't like to waste too much time.
Okay, sir. Just a minute.
Thank you, Chair. In the meanwhile, I'd also like to express my thanks to ISP, ICSP, 3S, and PTI for giving me this opportunity to share some experiences of mine. What I'd like to mention here is, I'm not going to look essentially exactly at what China has done with regard to this one, but I'm going to see the potential of geospatial imaging as such, and what it can do towards national, coastal security. This is what I'm going to generally talk about. Obviously, I'll be bringing into some extent what China has done, but I'd like to show, its capabilities to quite some extent. Thank you, Aishwarya. Let's go to the next slide. So this is what I'd like to cover quickly. I think the Indian Ocean region, maybe I'll skip because of shortage of time. Everybody knows what its capability is. I just want to make one comparison between what the concept note says and where exactly this one, where we are. And I'll just go to make a remark. We may have capability, but we have missed many times, like people keep saying, we missed the boat for lack of strategizing. I want to bring about how space is an enabler for security, and the Indian Earth observation capability, some examples, the A2AD, this one. Underwater domain awareness, I think the previous speaker has covered at great length, but I just would like to stress the emphasis on the need of it, and then I'm going to conclude. May I have the next slide, please? I think we'll just skip this because I just want to show the extent of the area and the crucial part the three straits, Malacca, Sunda, and Lombok Straits play in joining the Pacific and the Indian Oceans. And the traffic and other things everybody's talked about in terms of the third largest ocean, what the area it covers. Let's go to the next slide, please. This, I thought I'll just took a few leading phrases from the concept note, and I just wanted to add a few comments on it. So once the concept note says China was way behind India at independence in almost all spheres of development. It's mostly true. In the 50s and 60s, when we looked especially at the aerospace technologies, we were on par, I should say. In aeronautics, we were ahead. Okay, but China has progressed ahead of India in technology and in three spheres: nuclear, missile, and space, which I think the three government-run departments are fairly in advanced in India. I think we have this one. So the Chinese, for example, did the first nuclear test in 64. We did in 74. There was a 10 years gap at that time. They did the first missile test in 1960. We did only in 80. We had a large gap. They did their satellite launch in 1970. We managed the first one in 80, so 10-year gap. But over time, this gap has only increased. India's capability, however, in space, though behind China, is substantial. And in terms of the Earth observation and imaging, I think we should more or less on par with the world, I should say. PRC has overtaken India in technology field, but notably in terms of comprehensive maritime power. Okay, we have good at technology development in terms of capacity building, exploitation, strategizing. We stand behind. May I go to the next slide? So these three key departments, atomic energy, ISRO, and the DRDO, which are essentially the major ones, we had all the nucleus of doing very strategic capability way back in the 60s and 70s. The atomic energy was looking at the compact nuclear reactor. Some study they had initiated, Navy was interested in it. They ended up characterizing all the fissile material and carried out an implosion device in 1974. There was support from DRDO with regard to the explosive lens development in that. They also started some work on the special weapons development. And if you take ISRO, we had also the beginning of the single-stage rocket, an indigenous effort, and onto the satellite launch vehicle. But due to various circumstances, for example, ISRO was a civilian organization, political constraints, money, resource limitations, and all that, things really did not take shape the way China's managed to strategize. Next slide, please. Next slide, please. So if I look at, can I go to the previous slide? Yeah. So I just want you to just look at the last bullet here, because all the other bullets are fairly well known. The last bullet is Indian coastal and insular assets are within the range of ballistic and cruise missiles, especially in our context between China and Pakistan. And some of these missiles can be launched from ships and submarines also. So this is where our strategic as well as security dimensions increases, how exactly we're going to look at and maintain a certain amount of security requirement. Next slide, please. Next slide, yeah. So here I find space is a great enabler. Earth observation satellites today provide imageries in multispectral bands with high resolution. But I just want to bring it here. Today, there are approximately 2,666 satellites in orbit. As of March 31st, this is the number of satellites. US leads the game with about 1327. But China has 13.6% of the satellites in orbit belong to China. And the type of number of satellites imaging as well as the intelligence gathering satellites, I think more than 30 which they've deployed over to cover the Pacific Ocean. They literally have 24/7 hours of coverage. So we have a long way to catch up on that. So I just wanted to mention that. So in addition to the Earth observation, you require the intelligence gathering satellites, which can provide enabling data and locate radiation sources. There's also other defense sources like the anti-aircraft gun batteries and things of that variety. You can very clearly make out from the Earth imaging satellites. Today, in addition to whatever ISRO can do, there's a lot of improvement. Commercial imagery is also available with resolution of 1 meter or better. So you can buy and do this one. ISRO has good capability in this domain. We have 17 Earth observation satellites in orbit. And the Indian Carter satellite, I'm sorry, the last, this one. The resolution is better than 1 meter, as close to about 280 centimeters is the type of resolution that is possible with the Cartosat 3. Next slide, please. So as a satellite, again, towards the marine domain awareness, they can play a very leading and supportive role. So surface vessels can be tracked using land, ship, air, and spaceborne sensors. And the spaceborne sensors have been used to give this image, which you can see the number of seagoing vessels that have been put from small to big to everything that have been put. This is put by a commercial organization which gives the marine domain awareness data. And in this, the ELINT optical and radar can provide a useful information on carrier battle groups and other naval this one, but difficulty would be to how do you distinguish a naval battle group and a commercial shipping this one. That becomes the difficult job. For other traffic, long range information and tracking, LRIT, automatic identification system, AIS, merchant ship information system, they're all available, and these are tools for locating and providing the MDA. However, many of these depend again on the satellite for relaying the information. So collecting the data from this one as well and relaying it, you require a satellite gives the best relaying system. In addition, the humanitarian assistance, disaster relief, which also is run, and many of the satellites carry a search and rescue beacon, so they provide this type of service also. And because all this domain surveillance is not totally possible by one country, it's quite often useful to have a international cooperation in this regard. Next slide, please. So India, as I said, we have today 17 constellation of 17 Earth observation satellites. So this is over time, the resolution has continuously increased. And today with Cartosat 3, as I mentioned earlier, you can get a resolution of the order of 280 centimeters. So most of our satellites are in what we call the polar orbit. This is called sun-synchronous polar orbit, wherein the equatorial crossing of the Earth observation satellite is more or less kept at around dead, where the visibility is good, maybe around 10:30 a.m., where the illumination is good, and you get this one. So these constellations therefore keep tracking, and you get a fair amount of good revisit time with this constellation. But this is useful only for the fixed assets, not the mobile assets. So for mobile assets, you may require something different. Now, in weather conditions like today, the optical imaging satellites, the Earth observation using optical this one, not extraordinarily useful if the weather is cloudy and rain up in South India today. And not extraordinarily this one. At night, they are not able to really again distinguish. So for that, you require radar imaging satellites. Fortunately, India has already got 4 of these, good resolution, and the latest, the Earth observation satellite 1, was launched as recently as 7th November, sorry. So you have these, therefore, can provide you day and night all-weather imagery. And in addition, you have the OceanSat, which gives you certain ocean temperature and other details, wave details are available. So ocean state conditions can also be predicted. Some of the INSAT satellites also carry a weather radiometer, and you are able to predict the weather to a large extent. So this, therefore, we have a fairly good constellation of this, and this information is useful. And some of this how we can use, I'll explain in the next slide. Next slide, please. This is this one. This is not using Indian satellite, but Google Earth imagery. Historic imagery is available. This is I'm showing as an example. So what we can do, sitting in NIAS, looking at Google Earth imagery. Intelligence agencies better equipped with better this one in terms of coastal security can deploy these tools for much more. So as our coastal capabilities, defense capabilities are exposed as this facility which I have looked at using commercial imagery. This is a place called Winder, somewhere close to in Balochistan, not too far from Karachi, where the Pakistan launches its missiles towards the Gulf of Oman. So this is the normal trajectory, and of course this one. And in Winder, there is a launch pad where it is there. This is a mobile shelter. This is a transport in which they would have brought the missile. This is somewhere in November 2001, this picture is taken. And in December, I think it's on 12th December, we see the mobile shelter has been moved out. This perhaps brought the missile, and the missile has been now loaded onto the launch pad. So this is visible. And on 28th, the missile is erected and ready for launch. I'm mentioning this because we were just looking at, normally, a missile, if you're launching over the international waters into the sky, you need to give a notice to the airman and notice to the mariners so that the commercial shipping, civil shipping, and civil airlines are not really brought into any danger. So the time at which a launch may take place, the window over which it should be, international shipping should not come in that zone and all that other zone. So zone is declared as to where exactly this flight path is, trajectory, and how high, and where the impact zones would be there. So this NOTAM we tried, it was available, And from this, we could make out this is a Shaheen-3 missile with a range of about 2,700 kilometers. But in this case, the normal press release which comes from the interstate inter-services public relations was missing. And we could sort of conclude saying that most probably this missile test was a failure, must have launched its missile because there was no publicity accorded to this in the subsequent. Next slide, please. So we also did, this is, I'd like to thank my colleagues, Prakash, who's attending this, and Amit. They did a study on the Makran coast, and these are some of the images that are available. So looking at the congestion in Karachi as well as what the buildup that's happening in Gwadar, more security requirements were there, and therefore a lot of development has taken place around Gwadar. These are the pictures which just show the extent and the type of assessment my colleagues have made here and the buildup that's available. So this can be interpreted. There's an Eastern Bay Express, there's a fishing harbor and the Gwadar, this one, special economic zone where the cranes are placed, the Chinese labor.
Sir, you have 5 minutes left, sir.
Sure, okay. So all these details are available. Next slide, please. This is another, this one where slightly more important in terms of their Turbat terminal also houses some of their reconnaissance aircraft. There's an old runway, new runway. So a lot of details can be made out, including the aircraft here. So aircraft hangars. So details can be made out using the geospatial messaging. Next slide, please. Let's continue the Makran coast. This is another, this one. Before we go to the next slide. So if I just want to look at the maritime space requirement, therefore, you require revisit frequency as frequently as possible. But today, from the satellite capabilities that we have, revisits of the order of 1 to 4 days are possible. In communication transponders, we have good capability, but we need to increase the capacity. Now, if you take data in real time, if you want to locate it to your ground center, you need, therefore, what you call a tracking data relay in satellite in geosynchronous orbit, which can collect this data and transfer it down. This is just not here, but about plant will be there. So for 24/7, this one, you require a much larger constellation. As I said, of the order of at least minimum of 18 satellites would be required. And you require space-based sensors if you want to detect missile at launch, because the flight time from close by is very, very short. You require a good decision making, require more time. So large capacity increase may be required. That's also being addressed. Can we go to the next slide, please? Next slide. I just want to just no, previous one, please. The China has, with their constellation of satellites, they are able to track the US Pacific fleet or any fleet, any carrier battle group in this one. So essentially, they depend on the space segment comprising electro-intelligence satellites, Earth observation satellites, both the optical imaging as well as the radar imaging and the tracking data relay satellites to catch the carrier battle group with all the electronic noise and aircraft carrier makes to catch first, find a course fix on it, then use the Earth observation satellite to put a closer fix, and through TDRS pass it down to the ground command station. And once it's coming within the range of the over the horizon radar, other elements, the radar follows it up, the satellite provides a redundant data link, and then you have the satellite, the missile with a maneuvering warhead which can target the carrier as such. So they've put a very neat system in place so that tomorrow, in case the Pacific Fleet comes in front of for Taiwan support, they are able to signal the Americans we are on the lookout. Next slide, please. So this is another, the Chinese submarine in Karachi port. Again, the imagery is caught on. It was there for quite some time before it was caught on. Now this, if you want to look from image, till recently, this tender used to accompany the Chinese nuclear subs. But over time, the subs have gone into an operational type of status. and this tender is nowhere close to it. So this as a giveaway is not there. So therefore, other means of underwater domain awareness would be required to track the Chinese submarines. Next slide, please. So you require an array of underwater sensors to locate the submarine movement, whether you can put somewhere in the vicinity of the Malacca Straits or the Sunda Straits and this one. Then this sensor data you require again satellite to collect the data and pass it on. There are other difficulties, obviously, with the interpretation interaction, as the previous speaker has just mentioned.
So you have a minute left, sir.
Yeah, I'm coming to my concluding slide. Next one.
Yeah.
Next slide, please. Yeah. So in conclusion, I just want to mention geospatial surveillance is an essential and useful mechanism for MDA, and in turn, its application to coastal security. Analysis plays an important role in locating and analyzing adversary infrastructure and capability. Given the short ballistic missile flight duration from our neighboring country, it is useful to acquire the missile at ignition using spaceborne sensors. Cruise missiles, especially the new category of hypersonic weapons, provide even shorter detection and tracking time, and therefore you require again space sensors for this. Sensors in space are in a position to provide that extra few minutes of reaction time. Underwater domain awareness needs greater attention. Transition through the Sunda and Lombok states in where water close to us. And more worrisome to us again is the Pakistan Navy now fields Babur 3, a submarine-launched nuclear-capable cruise missiles. The range is not very much, but this missile is very much close to our its one. And major increase in Earth observation satellite constellation is required. We require major capacity building if you want to, along with supported system if you want to track carrier battleproof from a distance. Thank you for your hearing. I hope I've not run out of time. Thank you, Aishwarya, also for helping me with the slides. Thank you.
Thank you, sir. You managed to stick to time. Now, this is to introduce the next speaker, Dr. Venkateshan. Dr. R. Venkateshan is a scientist and program director at the National Institute of Ocean Technology, Government of India, Chennai. He earned a PhD from Indian Institute of Science, Bangalore, and a PG diploma in marine pollution management from Annamalai University. He has also a PG diploma in maritime law from Dr. Ambedkar Law University and a DSc from the Commonwealth University. He holds two important positions: UN bodies, chair of GRA of UNESCO, IOC Paris, and vice chair of SGOOIS Geneva. He teaches at IIT Madras, Kharagpur, Bhubaneswar, and is a member of the Research Advisory Board of Virginia Technology India, AMET University, a Senate member of Periyar University, Salem, and a member of the Tamil Nadu State Coastal Zone Authority. Welcome, Dr. Venkateshan. We'd like to listen to you. Thank you.
Am I audible now?
You're audible. You're audible now.
Yeah,
Please
is
continue.
it presentation seen now?
It's coming up.
Yeah, I hope it will come. You are presenting to everyone, it shows now. Good afternoon. Thank you very much. Thanks to Commodore Shekhar, and he has been asking me to come for this presentation. I have been listening to this talk from the morning. It's really enlightening, and I learned a lot from this discussion. It is a very important topic what we are discussing today. I would be presenting about our India's role as such, or the proud moment for us, how we have started working in the field of ocean observation from 1997, how we have grown, and globally how we are present now. It's not coming, sir, now. I think file size is big. Can Aishwarya help me to show me the PDF file which I sent you?
Aishwarya,
Yes, sir.
please start sharing the PDF file.
Yes, sir.
Otherwise, I will try my PDF if that is not possible.
No,
Because,
Aishwarya will help you out, so you can just give her 2 minutes to set it up.
Yeah, because the PPT had some animation. Unfortunately, size is big. So PDF should be okay. So basically, to start before the presentation is made, I will continue that. Ocean observation is how you collect data from the ocean. Today we are having a cyclone in Chennai. Very important to know about what is happening in the ocean. So we know Earth system as a whole component comprising of atmosphere and ocean. So the observation and collecting data from the ocean is very, very important. Next slide, please. Very, very important for us. So keeping that in mind, Ministry of Earth Sciences, earlier it was called Department of Ocean Development, started this National Institute of Ocean Technology. Next slide, please. Yeah, this is to say that we see more sea than others see. So we always say that this particular subcontinent is blocking the connection between the polars like Arabian, like Arctic and Antarctic. That's the difference we can say between two major oceans, and that's affecting the monsoon, that's affecting the what we live here. So that's why this particular subcontinent of India is placed in a very strategic way, and we need to look for an observation. Next slide. So what I'm going to talk about today is what are the observation techniques and technology we have developed, how far we have gone ahead. In fact, today our team is in Arabian Sea. They are servicing a tsunami buoy systems of close to Makran region of Gujarat coast. Next slide. So the importance of Indian Ocean is such that it is covered with more than 28 countries, both in the Asian side as well as on the African side. Knowing about monsoon and the climate change, we know that the Indian Ocean has warmed up, say, half a degree more. So there is a need to understand about it. So there is a need to share the data so that the whole Earth system prediction after the tsunami, there is a need to know about the coastal hazard has become much more important for us. Next slide. So why do you need to study the ocean, even for the climate services, if you talk about it? This is a way, the time scale of climate variability and the ocean, it plays a major role. You can see that atmosphere, it happens in the minutes, and whereas in the case of surface layer, it is coming to the days and years. When you talk about deep ocean, which is completely undisturbed. Last month, I was chairing a session in deep ocean activity in the case of ocean science and scientific component, wherein we can clearly say that differences what we see on the surface be felt even at 4,000 meter water depth. So then ice sheets, that is talking about millions of years. So we live in a biosphere. Next slide. So coming back to the importance for us, the coastal hazards like storm, cyclone, tsunami, coastal floods, storm surge, that makes us to know what is happening in real time. Even satellite imagery is doing wonderful job today. What you are able to predict mainly because of the satellite development technology which has happened, and thanks to the ISRO. But the sea-to data is very important. Here, this observation, what you have installed at sea, is really playing major role. Next slide. So if you look at this region, is really large amount of population is there, even 100 kilometers. We know that any coastal hazard, any disturbance, what we talk about, leading to major the effect in the human population as well as the infrastructure, what is happening over there. Both in the we call Northern Indian Ocean in the scientific context, like Arabians and Bay of Bengal, you may look at it, both are same. It's not, Arabian Sea is more saline and Bay of Bengal has got a freshwater influx coming from Ganges, Brahmaputra and Irrawaddy. That is making it more complex. That's the reason 4:1 ratio of more cyclone coming over Bay of Bengal. So even there is an international community trying to understand about Bay of Bengal, mainly because of larger influx. I can talk in length about how it is affecting the economy, how it needs to be studied, what we are not understood. The ocean as a whole packet is different. The fluid dynamics or understanding about the temperature variation is fine. But the atmosphere as a whole, fluid we call it, that is different. But the challenge is how do you understand the acid interaction, that is 0 to 5 meter or 3 meter between the connection between the. So that's what is happening. You are also amused why this Niva cyclone is outside the coast for a longer duration. That's mainly because it's SST, which we are monitoring over there. So there much more need to be understand about our own waters than to talk about it more. Next slide. Keeping this in mind, there is a very large program of Ministry of Earth Sciences. I can say that we are at par with any other international agencies like US, Canada. I am also part of many international committees. When we go there, we can proudly say that our observatory capabilities, our understanding, our modeling effect, how this data collected has been getting into the model. Our Indian Institute of Tropical Meteorology in Pune, NCMRWF in Noida, as well as India Meteorology Department, as well as in INCOIS. So you need to look for a different way. How do we measure? There could be one system we call Eulerian, where it is positioned and anchored in one location. Whereas Lagrangian, it keeps along with the water column, keeps moving it. So we have a system which is called moored buoy. We have a drifting buoy. There are also newer tools which is glider. Glide is an autonomous tool which works on a principle by which buoyancy variation is making the system to dive down in a pre-programmed way, and the way forward is can be always fixed, and it pops up to the surface and transmit data. So power is required only to transmit the data. Thereby, we know that autonomous system would require for more energy system. Here we can reduce in such a way that this can last more than 1 year, 2 years. Same thing, RO floats which can dive down to 2,000 meter depth. We are thinking to go for a 4,000 and 5,000 meter depth. Not only physical oceanographic parameter, biological, chemical. So our understanding, like El Nino, whatever we talk about, even IOD, which is more specific for our own region, for Indian Ocean, all these things have come to a better picture now by having this observation. We had 20 years of observation. What we got it very simple in one line. The scientists have really, the professors from Bangalore have brought it that before the deployment of Mood Boy, it was understood that Arabian Sea behaves similar to Bay of Bengal. It is not so. There is a lag. There is a change in variation when the monsoon pattern variation takes place. That was mainly possible by having continuous observation that is linked to similar to Pacific Ocean. Next slide. We also got a shipborne measurement. Our own ships, they collect data. I would concentrate on mostly on Mood Boy network, where we have got specialized and we have got a reception station. This is a network presently functional, 12 Mood Boy, which is having subsurface measurement, complete state-of-art technology we have. Up to 500 meter depth, we are measuring temperature and conductivity. We also measure current underwater. And above surface, not only meteorological, we also measure the surface incoming and outgoing radiation. That's a very, very important parameter to know how much radiation, solar radiation is coming into that. We also measure the rainfall. So this is being transmitted in real-time mode once in 3 hours. Of course, after the 2004 tsunami, we have got tsunami buoy system established close to the Nicobar region as well as the Makran region. We do have for satellite validation a Caldwell system. So this is in a nutshell. Of course, one more we have in Arctic. I will explain about. Next slide. So this, unfortunately, this is the animation to say from 1997 till now, more than about 600, close to 600 deployments and retrievals we have done. That animation not working. Every year, how we have grown, how much amount of data sets we got it, that was shown in this. Maybe if required, I will share my presentation in the PPT format. Anybody would like to see how we have grown. We started with the 14 parameters, and in way back in 2010, we imported with 76 parameters. We are close to about more than 150, 106 parameters, which is developed. We are able to transmit in real-time mode. Next slide. So this gives a complete picture. We also collaborate with NOAA under the Indo-US collaboration, wherein outside the EEZ, we jointly work with them, share the experience and expertise and our own shipborne facility. More than 25 Mood Boy systems are being deployed and jointly monitored. So that is also being used globally for many other studies. So this is in the nutshell to say the complete list I have given. The one right on the top is this one which is being deployed by NOAA. The important point, collaborating with others, we also learn a lot, because instrument is not just like that you buy and deploy, and no, it's not so. It requires for a more sensor versus data to be studied and how its performance to be enhanced. They are all left unattended for a period of 1 year, because we can go only once in a year to a site. So how do we enhance that? How do you ensure that? Because there is a group of countries and the experts are working on it and technicians are working, how we can share, that is to enhance so that the ship time is effectively used and to provide the valuable data. Here it's important is that at a particular location, if the data to be provided, the system should be functional at sea 24/7 and 365 days. And also air-sea interaction, we have a collaborative special program where in 15 education institutions in US and 15 in India, we jointly worked outside these in Bay of Bengal. And that has given us a larger important find. Special equipment were brought in. Indian students were trained. That is a spin-off of that. Next slide. So this is in the significant importance what we have done. We also studied about marine heat wave now, which is coming up, air-sea flux studies. We also work on freshening. That is very important. How the Ganges and other the rivers are bringing fresh water into Bay of Bengal. How this freshwater lens we call moving along the coast, we call it coastal current, going down to near to the Kerala coast and again returning back. That is being well established. Some of the things are theoretical, we could bring with the data. We also got a rapid mode data transmission. Even yesterday during cyclone, it worked and provided every half an hour data. That has been appreciated and published in World Meteorological Organization at their site when we provided the data during Amphan cyclone. The mid picture shows in one of the vessels where in terms of joint Please, next slide. And we too have research publications. We continue that. This is some of the cyclones. The important for us is during this harsh condition where even the wind speed goes to 200 kilometers per hour, the system should work. And by this process, we learned a lot. We know about atmospheric variation, what is happening, what is happening underwater. There is an upwelling phenomena. There is a changes of the water from the deep ocean is coming up because of these cyclone which is passing through the region, and how the cyclone track is varying. So all these cyclones could be tracked. I'm glad to say that the system remained at sea and provided data to us. Out of 6 parameters required for landfall prediction, 3 of them are coming from the ocean. Next slide. So this is the way the models are also getting fine-tuned. Unless you have that C2 data, model prediction won't be possible. Simply my model alone is not possible. To make the system functional is not easy. One has to sail continuously. So we keep sailing maybe 2.5 times more than the circumnavigation of the Earth. We could have sailed to make the system functional. And it's very hard work, and the team performs. And we learned a lot by having this system deployment at sea. And we have our own fleet of vessel. Particularly, we use Sagar Nidhi, which is having a dynamic positioning system to deploy such a specific system, because in the case of Tsunami Boy, we need a DP vessel. Next slide. This is
Dr.
very
Venkateshan, you have 10 minutes more, Dr. Venkateshan.
I'll rush fast. This is a measurement to show that this also for the industry application, continuous data more than 8 years we have. Next slide. I'll keep moving. This is on the tsunami. This is the Makran and the Nicobar on a plate where we need to have measurement. Next slide. We keep moving. This is what the Tsunami Boy system, where the subsurface tsunami meter is deployed. I'm also chairman of International Tsunami Meter Partnership. Out of 13 countries which are importing from US with one company, India is the one country we have developed our own Tsunami Boy whole system, which is deployed and continuously transmitting data. Since it is outside the EZ, under the UNESCO IOC agreement, we also share globe and we get the data from them. Next slide. This is a Caldwell Boy system for INSAT. We have got in Arabian Sea only one of its kind, where Twin Boy system, which is deployed, and you can see the continuous data being provided for validation purpose. Slide. And this is in Arctic. India started having our own observatory from 2014. More than about 30 lakh data points we have in Arctic. Not only physical, biogeochemical, including on pH acidification. We do have acoustic sensor in that. I will show you about a very important finding on acoustic measurements in Arctic. Next slide. And this is a reception station. Even during the COVID period, we didn't close down 24/7. It is banned. The state of art. I'm proudly to say that there's nowhere else in the world you have such a. It's not the screen alone. There is a tool which we have got to have the sensor tracking, augmentation, validation, where we have done calibration, anything you name it. We also have got a app which anybody can see the last transmitted data. And it's been appreciated by the visitors who had come and visited over there. It took some time for us. It's not just like that easy to develop such a tool. And there are also international companies who would like to buy this and use in their system. Next slide. And these are all technology development over the years we have done. Passive acoustic sensors we have deployed now on the request of Navy. Next slide. And this is different stages we have done. We have not been waiting. As we keep doing, every time we visit, we go for a changes. We also got few awards, National Geoscience Award from the Honorable President, and many other things we received it. That is motivating us to continue our activity. Next slide. This is one of the system of Minikoi, which is transmitting data completely indigenous. We buy the sensor globally. Everyone buys sensor from different industry because that is a specialty of its own. We need to have a very good data. There should not be drift between today what we are collecting even after 1 year. So that has gone through various technological development. So we buy the sensor and interface with our own CPU. Main thing is the data acquisition system, which is important. That is developed in India itself. Next slide. We have about 7 variants of data acquisition system. That has made us to develop this Tsunami Boy system, which is system only separately installed and acoustically linked to the 30-degree cone angle. To install at 4,000 meter water depth, you need a special expertise. It takes about 1.5 days. I'm glad to say that more than 300 times we have done, never we had a failure. Next slide. These are all some of the technology development. Next slide. This is a cost variation. We can reduce about 1/5, half of that. Next slide. And also we are planning to go for a INSAT. we're in close touch with ISRO. Maybe another 3-4 years for the telemetry completely it will be inside, because presently the footprint is not there. They are working on it. That's a major project we are doing, and that will help us to go for a complete our own system. This is a complete 23 years of data sets we have, 10 years of wave data, and 8 years of Arctic data. 6 years of Arctic data. All are archived and stored specially. Next slide. We give it to scientific community students. This is an integrated marine surveillance system. We can deploy and transmit data in 4G. Just got a video on still camera. Next slide. Underwater also is possible. And these are the appreciation we got from the global community, because our system is very simple, much more cost effective. They ask how it remained even in the high cyclonic condition. This is to say that we always want somebody to appreciate. Here is a classic expert from Utsal Oceanographic Institute. They have taken a design from us. Next slide. Next slide. These are all some video, underwater video in Arctic. Next slide. It's not working now. It's also a video where we have got a roboboat system which can be deployed underwater. It can use. We have also developed a robocoastal observer which has got a camera, and any other system we can use. Next slide. This is the Kallakadal, which is very prominent, where there's no wind, but the long swells come through that. We have deployed, and the system could predict and inquest if we wanted. This is also our own specific problem. We need to address this by having our own observation. It's not possible to do in any other way. Next slide. This is an Arctic measurement wherein we are completely monitored more than 3 years. We could clearly map about anthropony, that is from the phony from the propeller noise. Next slide. From the animal noise also we have recorded. Along the coast we also got in few locations. This is what is recently published in Nature, where iceberg calving and iceberg bubbling noise as well as a cyclone could be properly recorded, first of its kind, by having this continuously in Arctic, that is in Svalbard. Next slide. This is to show what is our presence globally. We are also part of the UNESCO Intergovernmental Oceanographic Commission, which I am also chairman of Global Regional Alliances. There are GOOS Global Observing System. 13 regions are there. Currently, India is heading that, where I convene a meeting and discuss with others on the data aspects. Particularly sustained observation, we need to know it. Unless we have it, it's difficult for us, like we have it today on coastal hazards and climate forecast, particularly for climate forecast. Next slide. Now, this is what is a three-dimensional aspect we are working. How do you go for an ocean observation system? How it has to be diverse? How an ocean information system should be there? So good governance is possible only by having a continuous measurements. That is being happening over there. Next slide. Within the EEZ, only the countries can do it. So we are propagating it. Every country has to do that. And outside the EEZ, we can share the data. Next slide. This is a year decade starting from January 2021. We are also part of that, where the ocean is really predominantly like a blue economy. It's going to play a major role. 6 different aspects have been divided. We can identify program projects linked to that, so that we are giving importance to ocean. Next slide, which is UN General Assembly is really focusing on that. We are in the advanced stage of discussion with our own sister institutions. This is the GRA I call, where the various countries and regional partners are involved, where India is chairing.
Dr. Venkatesan, you have 3 minutes to finish.
Yeah, just important for you. Next slide. Next slide. This is a smart cable where underwater cable could be used. There are about 1 million kilometer length cable is there. This Google recently found out that this cable, they normally do is a mechanical noise that could be used for prediction. We will be using it. We are trying to see whether tsunami could be predicted using this. There's no sensor, but observing the cable noise itself is possible. Next slide. Again, we are part of the international community to discuss about that. Recently, we published a paper, and my book is there in many of the US universities. I happen to see in University of Rhode Island. And this is about summer monsoon. This is published in Economist Journal, where clearly it has been brought out from the history and culture and the economy related to observation. Next slide. Where do you find? We also have trained students. Autonomous underwater vehicle competition we conduct. More than 20 AUVs are designed by students. Winning team we sent to USA. Next slide. Last year, the IIT Bombay team could be the close to the means out of 5 teams in the final, they could come compete about 46 teams. This is the way we are making these students to develop. They all shoot of that one industry has been established by students, and they are doing very well. They are also developing AUV and selling in Europe. Next slide. So where do you find China? this is a part of their own activity. They too have some presence here. They are deployed outside the EZ. Recently, we were asked to study one of the drifted moored buoy which has come and collected by Navy. We are given our report. This is to say that they are having this China Seas and some of the observation. They are also buying the buoy from US. Currently, they are trying to make themselves. Next slide. Still, they are not. This is a buoy design, what they are using. Next slide. They have a their data reception center, particularly for Argo. Next slide. And to conclude, to say that yes, ocean technology development, whatever you have done on the observation tool is very important. This knowledge could be shared, and that could be, we are also signed an MOU with NTRO. Indian Ocean region is very important. I have not shown you the EZ of many countries have not been observed. Unless we get the data, prediction won't be 100% perfect. And we have a global presence. Our activity has been well appreciated. We are also having the position at the international level. Dr. Shana is the vice chair of IOC, wherein we are able to articulate and understand what is happening globally. Deep Ocean means recently launched. You all would have read. Our ministry is really propagating on observing or collecting data, developing technology in the deep ocean. And you know very well, N-class sales is India's claim. Our sister institute NCPO are really working on it, and we are submitting. Man submersible is an important project under the Deep Ocean mission, which India is developing, and we will be having it in another 3 to 4 years. So satellite also will have with ISRO another 3 to 4 years. We'll be some completely self-sufficient in this observation technology once this satellite telemetry is achieved. So we are at right path, and this has been built on over the years, and the people working here have got a vast experience. We have also trained other countries like South Africa, now Peru, and they are asking us to train there themselves. Because next slide. To make the system functional is complicated. This is my team. Even currently, they are during the COVID time also they are sailing. They are doing wonderful work. Without their dedicated work on board the ship, I won't be able to present these data what has been available today. Next slide. This is the nutshell to say that surface, seabed to surface, the data to be transmitted within 5 minutes. We are able to do from 4,000 meter water depth to Inmarsat is 36,000 kilometer to the institute located in Chennai, which is a longitude distance of 1,000 kilometer. This technology is possible. We also measure from surface to atmosphere and coast to Arctic. This is what over here we have built on ourselves to understand about that. Next slide.
Dr. Venkateshan, 13:20 is your time. It's over.
Over, sir. I'm over. I'm finished.
Yeah.
This is my thanking slide. Thank you very much.
Yeah, there are a couple of questions for the panelists who can keep the questions the response very short and sweet. Thank you.
Asha,
Yes, sir. Sir, yes. There's one question from Mr. Danesh Sankyayan to Commander Arnab Das. The question is, how does stealth ships and submarines work if a moving object makes few decibels noise in underwater maritime context? And another question for Commander Arnab Das is from Prakash Panirselvam. Do you think India has capability to build wide area surveillance in the Indian Ocean to detect, track Chinese submarine? India has been purchasing P-81 aircraft for long range surveillance. How will it be useful to UDA? Then a question to Professor Rajaram. From Danesh Sankyayan. The question is, if satellites can track movements of submarines and even missiles, then why is it necessary to buy P-81 aircraft and Romeo choppers from US rather than investing in ISRO or DRDO? And one moment, sir. There's one question from Mr. Pratap Heblika, sir, to Dr. Venkateshan. Is Myanmar part of cooperation? I remember US oceanographic vessels have been visiting Moynihan in past. Can India, USA, Myanmar collaborate in this field? Those are the questions, sir.
Do I go first, sir?
Yeah, yes, please. Please go ahead with the answers because we are running short of time. You can finish the answers quickly. Thank you.
So to answer the first question, how does the stealth ships or submarines work in the noisy environment? Yes, that's definitely a challenge, and that's what I talked about, the acoustic capacity building, where we need to do a lot of shallow water acoustic measurement exercises. But there are a lot of signal processing algorithms that can be deployed. But the challenge there is we need a lot of data to validate our algorithms, and so it will definitely require a whole lot of effort by multiple organizations to come together and carry out such large scale field experimental trials. But algorithms, to some extent, I was also involved in the sonar classifier design for the nuclear submarine project, and definitely a lot more has been done. But I'm sure there is scope for us to work more and to kind of map every conceivable situation when we are out at sea. So that will require definitely a lot more work. The second question is about wide area surveillance. So firstly, I wouldn't like to talk about national capability because I'm not in any official position. But from a technical perspective, can PATI replace? But PATIs can only complement. But there will be definitely effort required for looking at underwater surveillance and a lot of sensor deployments, and along with sensor deployment, a significant amount of algorithm development will be required. I mean, that's what I talked about, the hardware versus the software. So hardware, definitely to some extent we can afford to start with, but the soft capability of algorithm development has to be done indigenously, and a lot more effort is required in that direction if we want to truly develop underwater domain awareness. Thank you.
With respect to the question that was asked to me, I want to make one clarification. One is, many of these performances are platform specific. Satellites cannot track subs. They have sensors. They are trying to develop, whether from the wake or something like that, whether we can make out, but it's still in a development stage. It's not really happening. Satellites also cannot track missiles. The sensor on board a satellite can track a launch has taken place. And if you want to track, you require a large constellation of satellites so that its movement and all that sort of thing can be tracked. So economically, as well as what is this one. So if you're able to track the plume first to some extent, ignition and then the plume, you can extrapolate or you can build on what may be the trajectory for the satellite, for the missile. Now, therefore, this being this one, and as I said, both these capabilities as far as India is concerned is still in the development stage, and probably I think we may be close to sensing a ignition of a missile. We may be close to that, but requires a lot more characterization, a lot more experiment. And as I said, ISRO is a civilian agency. Their priorities are quite different from what the security requirements may be there. The US aircraft platform is an anti-submarine warfare platform. It has certain tools. It is tuned to that. And both can only complement each other. I don't think one can replace each other. Thank you.
Like for video or thing.
Any more questions?
There was one for Dr. Venkateshan. If you could kindly take that up and then wind up the session.
Yeah, I can answer the question on Myanmar. Yes, there was a call to help the neighboring friendly countries. So we have given a proposal to the government of India. Added to that, we had one occasion where one of the boy got drifted away to Myanmar. Thanks to defense attaché, they helped us. So there is also a importance and a feeling given to us that this is possible. So earlier, we had a few years ago, NAOT had provided a tight gauge, and we had given a training program to the engineers in Myanmar and scientists over there. So they are part of our other global discussion when we have a meeting. About a few years ago, we had a meeting on the fisheries communities in the Myanmar. They have visited India. So there is a proposal. We'll be working on it. Thank you.
Yeah, I think we can end the Q&A session now. Hello.
Please go ahead, sir. Please wind up, and we can adjourn for. Move on to the next session.
Yeah. So I'd like to thank all the four speakers for their excellent presentations, very rich and very enlightening. And we'll proceed to the next sessions. Thank you once again.